Unit 3 Chemistry, Chapter 1, Part 2. So in this video we're going to look at different fossil fuels and we're going to look at the energy transformations that occur in them. Okay? We need to look at that to think about how efficient these energy sources are. In the context of fuels, when we talk about efficiency, we're talking about how much of the chemical energy we start with gets converted into the sort of energy that we're after. Okay? And in general, the more energy transformations it has to go through, so the more different types of energy it goes through when we do that, the more energy is lost, so the lower the efficiency. Now, when we say energy is lost, we know the law of conservation of energy, which tells us energy can't be created or destroyed. But sometimes it gets converted into a form that we don't want, like heat energy is the most common, but it could also be sound or light energy. Okay? So if we use, say, a gas burner, and we're using a gas burner in cooking, and we're using it to heat something up, it's going to go from chemical energy to thermal energy. Okay? Most of that energy, most of that chemical energy, does get converted to thermal energy, about 85%. Some of it will be lost as light energy. Yeah, because you can see the gas burner, so we know light energy is also made. Some of it might be lost as sound energy because we can actually hear it. Okay? But it's got a pretty good efficiency. 85% is very good. If we compare that to a petrol engine, ultimately we're going from chemical energy to mechanical energy. There's a few other transformations along the way. That's got a really low energy efficiency. So only about 20 to 25% of the chemical energy that's in that petrol, which is mostly octane, gets converted into the mechanical energy that makes your car move. Our fossil fuels. Now, if we look at our fossil fuels, they tend to be quite inefficient, but they are very well used. So coal is the first one. It's mainly carbon. It's got a pretty high energy content. Okay? And that energy content is the amount of chemical energy within it. We can burn it directly to provide heat, but very few people will have a coal burner in their house these days. It used to be quite common, but not anymore. Normally, we burn it in a power station and we make electrical energy. It makes a lot of pollution because it's got all sorts of other stuff in it as well. Releases lots of carbon dioxide, releases some things like sulfurous oxide and nitrous oxides, which make acid rain. And it's not very efficient. However, it's cheap and we've got a lot of it, so we still use it. Okay? So inside a coal-fired power station, we have got our coal which is burnt. Now that chemical energy is turned here into thermal energy. That thermal energy is used to heat up and boil water, which then turns into steam and moves. So now we've got some kinetic energy. That kinetic energy is used to turn the turbine, so it's kinetic energy in a different form. And then that gets converted to the generator, which converts this kinetic energy here into electrical energy. So we've gone through a number of different energy transformations. We've gone chemical energy to thermal energy of coal, to thermal energy of the steam, to mechanical energy of the turbine, to electrical energy from the generator. And each time we have an energy transformation, we are losing energy, as in we're putting it into a form that we don't want. So that's why our efficiency can be quite low. Okay? 50% of the coal's chemical energy here, lost as heat in steam. Crude oil is our second one. So crude oil is our second fossil fuel made deep under the oceans, mostly from dead marine animals, millions of years ago, remember? Okay? It's a mixture of alkanes, and we can split them up by fractional distillation. You don't need to know the details of fractional distillation, just know that the smaller something is, the fewer dispersion forces it will have, so therefore it's going to boil at a lower temperature. Okay? And we can separate it based on that boiling point. Oil is an important source, and many people say that people go to war over oil. Okay? And we can see on this, when we look at the fluctuations of oil prices, we can see certainly where there's the Yom Kippur War in the Middle East, or when we had the first invasion of Iraq, Okay? That's going to have a big impact on oil prices. Okay? But by and large, it's fairly stable, so it can be used well. Natural gas we have in our labs. It's what comes out of our gas taps. It's mostly methane. And we use it in home cooking and heating. But you can also use it to generate electricity. The power station in Newport, that is a gas-fired power station rather than a coal-fired one. Okay? When it's used in a power station, the energy transformations are pretty similar to those in a coal one. Okay? We use the hot gases for combustion to turn a turbine, which is attached to a generator, so it's slightly more efficient. But again, we're still getting less than 50% efficiency. So less than 50% of the initial energy that was in the chemical energy within the methane gas is converted into the electrical energy that we're wanting. Okay? All three of these are fossil fuels, so they're defined as non-renewable. And remember, non-renewable means that we are getting a replacement rate which is less than the rate it's used at. So we can't replace them as quickly as we are using them.